So we first start with the Klein bottle. The Klein bottle is almost exactly like a torus, but with a slight difference. So we first draw a two-cell, looks like a rectangle. We draw vertices. There is a single vertex. As you see, when we fold it up, all these four vertices will be identified together. So we have the top side of the rectangle, we marked it as edge A. The bottom also has edge A, just like in torus. The left side as B, and here we will see that unlike torus, the orientation is opposite. So you twist it when you glue the vertical sides together. So C0 is generated by a single vertex V, so it is the entire ring of integers. C1 is Z2. It is generated by sides A and B, and C3 is just the surface, the two cell. Let us put some lines here to show that it is a two cell. So let us now write the chain complex. C2 Z square, which is C1, and then C0. So we want to find the delta 1. Delta 1 of A is just V minus V, which is 0. This is same as delta B. So the kernel of map is the entire Z square. Now delta 2S is slightly more interesting. We first have to draw the orientation anti-clock. So start with at the bottom of the figure. A is in the opposite direction compared to the pink anti-clock. B is in the same direction, top A is in the same direction, and then B on the left is in the same direction. What we get is 2B. So this map is an injective map, multiplication by 2, image is 2Z, and kernel is 0. This is just Z, so this is what we get. What about H1? Kernel of delta 1 over image of delta 2. So we can see that entire Z square is mapped to 0. So we have Z square here. Image of delta 2 is just 2Z. So we'll just modulo it out, and what we get is this Z direct sum with Z by 2Z. What about H2? We have to only worry about kernel of delta 2. Now kernel of delta 2 is 0 because it's an injective map, it is multiplication by 2. So what we get is 0. We don't have to worry about whatever image of delta 3 might be. Anyway, in this case the image of delta 3 is also 0. Since we do not have 3 or higher cells and the chain is all 0, so we get 0 there.